Today we'd like to look at how to solve a problem in physics. This method would also work in other classes such as math or other science classes where a numeric answer is needed. So let's get our problem up here and we'll see how we go about solving it. Here we have a 1,200 kilogram car, starts from rest and accelerates at a constant rate around a circular track with radius 0.75 kilometers. The car does one lap and crosses the finish line with a speed of 200 kilometers per hour. Part A asks, what was the size of the force acting on the car? Part B, how long did it take the car to do the lap? Now what we'll do here is we'll find out what information was given to us that we need to use in this solution. And we also will list what we are asked to find. We have been given the mass of the car, the radius of the track, the final speed of the car, and the initial speed of the car, and we're asked to find the force acting on the car. Now, after we have all this written down, we will now put down the equations that we will use to solve the problem. Now, some of these equations you may not have seen before, but we will study them throughout the year. There's one here that I know that you should know, and you see if you can see which one it is. So let's list the equations that we're going to use. Well, the top equation is very famous in physics. Force equals mass times acceleration. That's the equation that we will use to find the force. But to do that, we need the acceleration. We're not given that, so we have to find it. So my second equation will allow me to find the acceleration because I know the final speed of the car, the initial speed of the car, and I also need to know the distance that the car travels around the track. Well, to do that, I have to find x, and that is the circumference equation, as you all know. It's a circular track, so the circumference is equal to 2 pi r. What we do now is solve the bottom equation, get x, put that into the middle equation, find a, then put that into the top equation to find what we're looking for, force, or F. And there we have the solution to part A. X turns out to be about 4,710 meters. With that, we find A to be about 0.328 meters per second squared. And with all that put together, we get the force acting on the car as 394 newtons. So now let's go on to part A. Excuse me, part B. This is a quicker solution here. We're asked to find the time it takes the car to make one lap. We use another kinematic equation, final speed equals initial speed plus the acceleration times the time. We now know the acceleration, we know the initial speed and the final speed, and we can solve that for t to get 170 seconds. So now let's review what we've talked about in terms of this method for solving problems. Read the problem, pay attention to what information is given and what you are to find. All the information given may not be useful for the solution, and you would not obviously use that information. However, there may be times where there is not enough information and you're asked to find that information. And so you can do that by looking in your textbook or online at some internet source. Secondly, we list the given and the find on your paper, just as I did in previous screens. List the equations that will be used in your solution. Start with the equation you will use to get the answer. Also list any other equations you will need in the solution. And that's what we did there in our solution screen. Solve each of these equations until you get your answer. Be sure to place units with your answer. You start at the bottom, work your way up to the top equation, and then be sure to put units on your answer. This is a science class, and we're not just looking for numbers, we're looking for measurements, and measurements have units. Finally, this point is often overlooked. Ask yourself if the answer makes sense. Sometimes this is hard to do because you don't know a lot about the metric system. Hopefully before the end of the year is up, you'll have more of a sense of the metric measurements. But let's say I got an answer of 1 billion newtons for part A. Well, 1 billion, anything, is a very large amount. So the car is a 1,200 kilogram car. It's about an average size car. So 1 billion newtons, probably not necessary. On the other hand, if I got an answer of, say, 1 millinewton or 1,000th of a newton, that may not make sense either, because it is 1,200 kilograms of mass, and 1,000th of a newton of force would probably not accelerate it up to 200 kilometers per hour in 170 seconds of time. So tomorrow you'll be given several problems to work in class on your own. And thank you for watching this video. I hope it has been helpful.